Okay, um, we're starting with the third chapter of the Koenig and Ritchie C book today. I'm assuming everybody's at least tried to read it at this point. If you're lagging behind, just try to stop lagging behind. It shouldn't be very difficult at this point. Actually, the hardest chapter in this book is definitely chapter 1 because there's a lot of new stuff at once. And after you get past chapter 1, it's kind of more comfortable because it's revisiting in depth the things that you have already seen before. And that's exactly what chapter 3 is about. Chapter 3 is about really looking at stuff like the statements we've learned, like the blocks of statements and why are we putting the curly braces and what do those curly braces mean. So in chapter 3, the very first thing that is explained is in section 3.1 that we have to put the semicolons at the ends of the lines and that we can make a compound statement, also called a block, to group some statements together. And where do we use this thing with the curly braces? When we want to do like an if or an else or a file or a war for, and we want to indicate which statements belong to that part, which are the ones that are conditioned or repeated, that's when we put the curly braces. I would recommend putting them even when you have one single expression. So basically, if we're looking at the examples in section 3.2 of the if-else, it becomes difficult to read the if-else statements. I'm going to post a screenshot from the book on the channel so you can see the part that I'm looking at. So basically, what's going on here is that the person who writes the code decided not to put the curly braces. So now we have to be guessing if this else goes with this if here or if it goes with this if here. That's uncomfortable. Even if people know which thing goes with which, never ever make them guess. If you want the second if to be inside the first if and the else to go with the outer if, just put the curly braces there. I would personally put the curly braces in both. So I will write here in Emacs, in a code I have no intention to compile, just to show how I would recommend doing this. So you would make the if n's larger than 0, then you'd put the curly brace. Then you'd put the if a is larger than b, and you'd put the curly brace. Then you put the stuff that you want to go in there. Then, if you want the else to go with the first if, you would write it like this. If you want the else to go with the first if instead of the second if, you would write this. So this is much easier on the brain to understand what's going on here, because even if the block contains one single statement, we are clearly showing the scope of the block. Where does this thing end? And this causes much less confusion in other people looking at our code, in what compiler tries to do, and what we ourselves understand when we look at the code later on. Section 3.3 discusses the if-else, if-else, if. So basically, we could add all kinds of conditions here. Like, for example, if A isn't larger than B, but A is an even number, then we could do this. And at the very end of everything, I'm having a hatred relationship on how my braces are placing themselves now. We could do something entirely different. So this is a really simple section. And the example they're using in this section is binary search. I wrote a complete code that you can actually run based on this binary search example. So this is the routine that they give in section 3.3. And I wrote a main routine that searches for two numbers in this ordered array. Binary search is only for ordered arrays, so the data has to be from smallest to largest for this to work. So I am making an 8-element array. I'm making a variable that says how many there are. So I can call binary search, look for 13 in this data that has 8 elements in it, or look for 82 in the data that has 8 elements on it. And in here we have the if else for whether the number is smaller, larger, or equal. And how does binary search work if you've never run into binary search before? It's kind of like how you look for something in a phone book. If you guys are old enough to have seen a phone book or a printed dictionary, you would just like open the thing in like a random place in the middle, and then you would compare. If you're looking for the word statement in a dictionary and you're presently looking at the word general, you know that statement comes after general, so you're just gonna like open in the middle between general and the end of the book, and you're gonna end up at another word, let's say terminate. And since you know that statement comes before terminate, now you're gonna search between general and terminate. You're not going to search before general, and you're not going to search after terminate. So you're going to be recursively cutting things in half until you reach the correct element. In this course, we're not going to be concentrating on how does this algorithm work. You have another course you're taking. You're probably taking computational algorithms or data structures, or like a programming workshop where there's more discussion on how these algorithms actually work. Our problem in this course is understanding what's a while, what's an if, what's a subroutine, what's a return, what's an int, and all of this kind of stuff. So we're just really focusing on how to write the programs, and you're supposed to be learning elsewhere how do these programs actually work. But I am still going to go to another, the person who just showed up again, I already put you your points. I'm going to go to another channel for a second to get you guys an example on how the binary search works. Apparently I can't find the binary search here. I knew I have it somewhere in the discrete math course. Let's just find it from the examples. Búsqueda binaria. This one. Let's put it here so we can look at it. So put it here so it's larger. So you have the ordered array. You want to know if an element's in it. You first compare it to the center element. You discard the half where it's impossible to have that element because the array is ordered. You compare with the middle, you discard. You compare with the middle, you discard. You compare with the middle, you discard. And if you run out of things to look at and you don't find the number, you will return false to indicate that the element wasn't present. If you're looking for something that actually is present, when you start from the center and then you go comparing with the center of the new half, you will eventually run into the element. So this is how binary search works, and it's written here so you can play with the code. I still think it would be a lovely thing to you guys write these examples on your own and adding the main so you can actually test them. But I'm still doing it for you because I think some people still need this. But I would like you guys to be able to do the exercises largely on your own now. In section 3.4, we have the switch case expression, which is a wonderful alternative for the if-else construction. If we are choosing a branch based on an integer or something that could be interpreted as an integer. Like for example, if you are doing like a Mario Bros kind of a thing, or let's say Pac-Man where you have to move like top, bottom, left or right, you could put those directions in a variable, code those like 0, 1, 2, 3. And then the movement, whether you go up, down, left or right, you could move with the switch case statement, where you look at the direction that's been chosen and the action you take goes in terms of the case clause. So I'm going to write you guys a tiny little example of the switch case, one that we can actually compile. I'm going to call it SC. Keep thinking I'm writing Python. Okay, now I just need a number to put to A. Let's use the conversion routine. From the first parameter. Make another window to compile in. Come on. So now what's going on here is that I take the integer, then I take the residue in division by 2. If the residue is 0, I print this stuff. If it's 1, I print this stuff. If it's neither 0 or 1, well then math is fucked and nothing's proper anymore, and we would go to this default option here. So all I need is something here that can be interpreted as an integer. And now remember, technically letters can be integers too, so I could technically just do like options A, B, C and put those in a character and put those in here. Let's add an example like that to the same code. I'm going to use the first character of the second command line argument in my second switch case. Oh well, this looks much better. Okay, let's try to compile this. So this is how a switch case works. We're going to put it in the repository. And we're going to make a little poll to see if we are okay with the switch case. Important things to notice are that I'm not putting the curly braces. The block for the case begins at the colon and ends at a break. So this is a syntax that's a little different from the others because we don't use the curly braces for the blocks. Few people need a little more time. It's okay to need time. Nobody's ever learned switch case by watching other people. You only learn it by using it yourself. It's impossible to learn this stuff by watching other people or listening to people talk. You kind of get an idea when you're reading the book, and then you need to test out this book. And if you have questions like, what happens if I do this and this? Just try it. Try, see what happens. Because the computer isn't doing like random chaotic things, it's doing systematic things. And by systematic experimentation, you should be able to figure out what exactly is going on. We're waiting for Edgar's question. I'm actually going to go get more tea while Edgar types. Okay, that's a very good question. If you've read section 3.4, you're going to know the default is what you do when none of the cases match. It's what it says here in the second paragraph of section 3.4. The case labeled default is executed if none of the other cases are satisfied. A default is optional. If it isn't there and if none of the cases match, no action at all takes place. I'm going to take a screenshot. But seriously, you guys need to read this book. Reading the book is not an optional activity. Bad things will happen if we don't read the book. So I think we're pretty okay with the switch case. Then section 3.5 is going to explain why the while and the for loop actually do the same thing, because it's showing how you could write a for loop just using a while instead. I am going to take a screenshot of that part too. And then there's a really cool loop that I hope you will at some point try, which is a do while. The difference between the while and the do while is that in the do while you do things at least one time before you even evaluate the condition, whereas in a while you first check the condition and then you start executing. The example in this section, which is section 3.5 on the loops, I also wrote one for you. I wrote the shell sort. This one sorts an array. So I'm using an array like the one I had for binary search. But here what happens is that first I use the cell sort routine to order the array, which means it moves things around, swapping elements from one place to another to make sure that this thing gets sorted. So it does 3 for loops, one inside another, moving things back and forth. And it puts the data in order. So what it's going to actually print, it's going to print the 1, 23, 32, 56, 63, 74, 82, and 92, because it's going to put everything from smallest to largest. So that's there for you guys as well. There's a very careful explanation of all of these things. The do while is in the section 3.6, also with an example. Really important you understand the difference between the while and a do while. It will be on the test. The section 3.7 talks about the break and the continue. Break meaning I don't want this loop to go on anymore. Continue meaning I don't want this block to continue anymore, but I would like to go to the next iteration of the loop. So I wrote here the trim example, which is the first example of section 3.7. So basically what we are doing here is that we're taking a character string. We are stripping all the spaces from the end. So as long as the character at the end of the string is a space, we keep pushing the n towards the left. so that eventually our position n reaches one that isn't a space anymore. So this is a for that will keep on moving from the length of the string towards 0 until it either reaches the end of the string or something that isn't a space. So as soon as I found something that isn't a space, I'm going to break, meaning that this for will no longer continue. Break means I don't want this loop to function anymore. Whereas a continue statement would be something interesting happened and I'm satisfied with this iteration, but I want the loop to keep going. We are going to need examples of this. Let's write an example somewhere. I'm going to call it BC because it's a break and continue example. We're going to pretend this thing doesn't have any arguments this time, just so you see that I can. We're also going to return a 42 just because I can. So let's take an int I and an int j. And then let's make another loop on the inside for the j. Let's make j iterate from I plus 1 towards 10. Actually, yeah, let's let it go to 10 too. Okay, so now I have one loop and another loop. So let's say that if I hit the point where 2 times I is the same as j, I no longer want to do this inner loop. I want to break out of it. Let's actually, I'm going to first comment this stuff out so we can see what this loop's going to do originally, and then we're going to enable the break. So let's make this thing just print two values that are going to be I and j. Let's compile this. My Pythonism shows I keep forgetting the F. So what it does, it prints 0, 1, 0, 2, 0, 3, blah, 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 up until 10. Then 1, 2, 1, 3. And then after those, 2, 3, 2, 4. So the second loop, it's always a little shorter. So that then when it's 9, it just prints the 9, 10. If I enable this stuff here, it will stop as soon as 2 times I is the same as j. For example, here 2 times I is the same as j, so this and this won't happen anymore. It'll be a shorter printout now. What did I break? Yeah, I have to move the print afterwards so that it doesn't print the exact match anymore. So now the 4, 8 and the 4, 9 and the 4, 10, they're not coming anymore. Because anytime I reach a point where twice I is j, I stop. This 4 stops. This other one keeps on going, but the inner one stopped. If I wanted both of them to stop, I would need to use a flag. I would have to make a flag that's originally false. Then I would have to set the flag here. And in the other 4, I would have to check for it. That if flag is still 0 and y is I is my less than 10. Now I break both loops. But if I don't use this flag here, I only break one of them. Let's put both options here. Then we'll make a third option, which uses the continue. We're not going to break out of anything at all. We're simply going to skip something. So we're not going to use the flag. Fuck. So now what does this mean? The continue means that instead of doing the rest of the stuff inside here, just go to the next value of j. So I'm going to need to print separators here. If. So that's the continue. That's the break with a flag. And this is the simple break. Compiling. Let's go to the beginning. So the simple break, what it does is when we reach the double, like the 4/8, it simply stops doing the inner loop. The flag break, it breaks out of both the first time that this happens. So when's the first time that this happens? It's when 1 and 2 are the values of I and j respectively. The continue, it keeps on going, but it skips all the cases where I multiplied by 2 gives j. So we can either break from 1 4, break from several 4s, or we can skip the rest of the block. Let's put this in GitHub. And let's make a poll. Green if you understood everything. Red if you have a question mark. Confused face if you're still processing this but you think you'll be fine. And this sleepy face if you just showed up and you have no idea what's going on. If you find yourself often confused by us discussing the book, it means you haven't spent enough time reading the book. It's really, really much easier to know what's going on here if you've at least read the sections. Like now I have more people that are confused that are not than people that are not confused, meaning that there has been some, let's say, lack of dedication to the examples, because there's a very clear example of how break works, and there's also an explanation of how continue works. So seriously, please read the book. If it's difficult to read on your own, please read together. And remember, anything you've misunderstood or skipped in chapters 2 or 1 or 2, it's hurting you in chapter 3. You can't skip any of this. You have to know all of this. And nobody has any questions, so I hope we'll be okay at some point. Section 3.8 is about go-to and labels. Please just don't do this. Just please, 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 please don't do this. You will hurt yourself horribly if you try. You will write horrible code. You will maybe 3 times in your entire life have a justified need to use a go-to statement in C. In your entire life. You will not have a need to do this in my homework at any point. There will always be a better way to do things than with the go-to statement. Just please don't touch it and we'll be fine. Let's make another poll. I understand that I have absolutely no excuse to use a go-to statement in my C code. during this course. Okay. Green, if you have understood, you're not going to use the go to. You're going to get negative points for homework that has a go to statement. Why do we not want to use the go to? Because instead of doing things right with break, return, continue, if, you're just going to start writing horrible spaghetti code, misusing the go to statement. Because you're just going to think, well, I'm just going to tell it to go to line 13, then I'm going to tell it to go to line 7. Nobody's going to understand your code, not even you yourself. So just please, please, please don't do it. So we should have the examples I wrote on GitHub. And actually shouldn't close these all because I'm still going to do the second homework for you guys. But first we're going to look at the stuff we need to answer in the mini questions here. So we are now in the chapter control flow. Let's zoom in a tiny bit. And look at exercise 3. So in this first one, you get values for A and B, and you will put them here in start and stop. I will take the value of start. You don't put the A here. You just put the A here, because this is a declaration. Then we have a variable count that gets incremented inside this do while. I gets decremented until it falls to stop. Before you run the program, try in your head to figure out what number it should print. Like if we start at 50 and where counter starts at 0 and we increment the counter, decrementing I, and we will quit when it reaches stop, which is 12, what should be the printout? First, reason it. Once you reasoned it, run the code, and here you write what's the printout, like what's the number that it printed out. You don't need to put the new line, just put the number printed out and you'll be fine. So the point of this exercise is to make sure you understand how do while works. In the second one, we have again a start and a stop. A and B have those same values as in the first question. Now there's a C that takes value 3. So now this is similar. There's still a do while, but there's an if with a break in between. So now you need to understand when will this break activate. So at which point will we stop incrementing the counter because of the break. And this one is a modification with the same values A, B, and C, but it doesn't have a break, it has a continue. And here we're dividing the count by 2 inside the if, whereas here we weren't doing anything to the count. So try to do these by hand first. When you've done them by hand and you know what's going on, verify with a code that you're actually correct. If your reasoning wasn't correct, then take a little time to consider that maybe you've misunderstood how whiles and do whiles and ifs and breaks work. Once you've done those 3, you are going to write this program. So we're going to be reading from standard input, which is getchar. Please try to use getchar if you could. And you will be producing in standard output, which is either putchar or printf. You are going to take characters one by one. Whenever the character is a digit, you will replace it with an uppercase X, regardless of how many digits there are. So if I write hello 1, 2, 3, the 1, 2, 3 will become a single uppercase X. Except for when the number in question is enclosed in one or more sets of parentheses or quotes of any kind. So if I type hello parenthesis 1, 2, 3 parenthesis, that 1, 2, 3, nothing's going to happen to it. It's going to stay normal. But if there weren't any parentheses around it, then it will become an uppercase X. All punctuation will be omitted. So if there's a full stop or a comma or a semicolon, that's not going to be output at all. And any other input is reproduced just as it is. So let's think about what would be happening here. If I give it an input hello, it will give an output hello. If I give it a hello that has punctuation in it, the punctuation disappears. If I have numbers that don't have any quotes or parentheses in them, those sequences of numbers will become uppercase X's. If, however, they are in quotes or parentheses, nothing will happen to them. Writing a couple more examples. If you are confused, please write me what you would give as input, and I will write what the program should give as output. I'm going to make a poll to see if anybody's going to write anything. So this is a really easy homework. If you've done homeworks 1 and 2 well, you shouldn't struggle with this at all. You're going to be using probably an if, else if, or a switch case to put flags up about whether or not you're inside parentheses. You kind of need to remember how many of which kind you have, because you need to track the closing of the parentheses as well. Like, you need to know when a parenthesis is closed, because if it's not enclosed, it's not going to work. If it kind of works, you're going to be getting 1 or 2 points. If it really works, you're going to be getting 3 points. You don't have to do any subroutines. There's going to be loops. There's going to be fors or whiles or do whiles. There's very probably going to be ifs, if else's, switches, probably breaks or continues. The design is yours. And guys, I don't want to see 40 times the same program. It's okay you help each other, but it can't be the same program for everybody. There's so many ways to do this. You learn nothing when you take somebody else's code. Nothing. You will become a horrible engineer. You need to do this on your own. And remember, if you start struggling while you're making the homework assignment work and you're not sure what it should do with a given input, just type it on Discord. Please don't tag me if it's not working hours. Like, if it's Sunday, 3 a.m., I really don't need to be tagged. You don't have to ask me. You can just ask anybody, and the first person to see it will respond. It's a little bit offensive when you guys sometimes suppose that I work 24/7 and I can answer you guys any questions like anytime. I actually don't. I do stuff like sleeping and eating and exercising, so it's a little bit troublesome when you guys are like, hey teacher, and I'm like, yeah, it's kind of like 6 a.m. But you can just type on the channel, not mentioning me, not tagging me, and whomever strolls along is gonna help you when they can. That's entirely fine. You can do that anytime. And nobody's gonna send me direct messages. Everything's gonna be here on the channel. So if you've understood homeworks 2 and 3, you can go now. What I'm going to be doing between now and 5 o'clock is I'm going to write a code to, Andres, those are not quotes, those are parentheses. So basically, I would take any kind of parentheses. But like, since this homework isn't automatically graded, we're grading this manually. It's not that sensitive how exactly you do this. Okay, I'm waiting for the conversation on homework 3 to conclude. Then we'll do homework 2. I really wouldn't use a lot of arrays. If you want to, you can, but you don't really need to. Like, you're gonna make it more complicated than it needs to be. Try it without. If you can't figure it out without, then use arrays. I'm gonna make a not very efficient way of doing the homework too. Like, I'm going to check for each number separately whether it's prime, but I just want to make this as easy to understand as possible. The other way around. So numbers 1, 2, and 3 are prime numbers. Whereas for numbers that are larger than 3, we need to do the divisions. If it's a prime number and it's if it's an even number and it's larger than 2, then it's not going to be prime. In other cases, we need to try the divisions. We could actually do the assignment here. We can actually even declare here. Maybe it optimizes the compiler a tiny little bit. We need to keep going until we need the math library, because we need a square root. If you want to know why we need a square root, you can go watch the homework on prime numbers on my simulation course. There is an extensive discussion on where does this square root come from. I'm actually going to do an int of the ceiling of the square root of n. And we're not going to divide by the even numbers anymore. We're just going to go with the odd numbers. If n is evenly divided, exactly divided by division here, then it's not a prime number. If nothing divided it, then it is a prime number. So what we have now is a routine that checks if numbers are prime. Let's test it. So we're going to be printing n. Then if prime n gives true, we are going to be printing nothing at all. If it wasn't true, we're going to print not. Let's try compiling this. So for from 11 to 19, we are checking if these numbers are prime. Okay? So now I don't want to check it from 11 to 20. I want to know a specific amount of primes. So let's first get the amount. We're going to need to use the conversion routine, A to I again. We're going to take it from the standard library. And then we're going to use while. So we need k primes in total. Let's make a counter here. While the counter is smaller than k, we're going to keep going. And let's put the primeness in a variable. And we're going to increment our counter anytime we do find a prime. And now we could actually change. I'm just going to leave the printout like that for now. Compiling again. Oh, forgot to give it a number. Let's ask for 5. I know we're not incrementing n. So n is going to have to start at 1. And we need to be incrementing n after we test it. Come on. Compiling, running. So now it gives 5 that are prime. And it's... why is 5 not prime? Oh, okay. Square root of 5. If I round it up, square root of 5. Okay, so we need to make sure that it's also smaller than n. Compiling again. What on earth? I'm gonna have to print stuff to understand what my problem is. 5 is totally prime. Printing n and div. See what's going on. It's never printing any of this stuff. N starts at 1. It's also starting with the... Okay, I should probably... Let's separate the n++ here. Or am I running some other version of the code? Technically, Rogelio, technically you could declare a variable inside of 4. I wouldn't recommend doing it. What on earth is going on with my code? Okay. So n starts at 1. 1 should totally be a prime because 1 is smaller than 4. It should never go to the divisions. K is the first argument we have. C starts at, oh, okay. C needs to start at 0. It can't start at some arbitrary value. It should still test the 1 first. While C is less than K, we check if this is a, oh, okay, it's because we're printing before we're incrementing. Okay, prime, prime, not prime, prime, not prime, prime. Okay, this looks much better. It's a bad idea to increment stuff before you print because it's going to print incomprehensible things. It was trying to tell me that 4 wasn't prime, but it was telling me that 5 wasn't prime because I had a classic off by 1. So now I have exactly 5 prime numbers. So now the problem is that I'm printing them while I go. But I need to know how big is the largest one because I need to know how many binary digits the largest one is going to occupy. So let's make the thing that tells us how many digits. So let's call it bin digits. We're going to give it an n, and it's going to give us how many digits we need. And we learned this in one of the little homework assignments. It's going to be the integer that's the floor of log 2. We're going to make a function for log 2 of n plus 1. Okay, so our log 2 of n is actually just going to return a natural logarithm of n divided by a natural logarithm of 2. So now we have a bin digits here, and we need to find the largest. Let's put it in L. I have a parenthesis missing somewhere. Not sure where. That closes the floor. Why doesn't he want to go inside? Well, the compiler will tell me in a second. So what I want is the largest one of these. So anytime I find something that actually is prime, I need to update the largest. So if P is a true, then the largest is going to have to be n. We're going to compile to find my error. Okay, log 2 already exists. Great, my compiler already has a log 2. But let's make my log 2. It still didn't fix everything. Just so you can see that you could make your own log 2. Okay, now it compiles all fine and mighty, but Emacs is still horribly confused. Let's do the right thing for C and move all the routines underneath main regardless. Like, we're only supposed to be declaring them there up top. We'll talk about H files later and implementing them down here. So let's just make a declaration that says that this one takes an unsigned int. Oh, I'm writing like it's Python. That's the problem. I'm writing like it's Python. I'm not giving the types. Now it's all happy. Okay. So now what I actually want to know is the largest one. Let's print here the largest one and how many digits it has. So I'm printing L and bin digits of L. let's look at this. Okay, so 7 needs 3 digits in binary. It's 111. Okay, so now if I don't want to use an array and I know what's the largest one, what I'm going to do is I'm going to use this loop once to find out what's the largest one. Once I know what the largest one is, I'm just going to do it again. So and we're going to write this a little shorter. L is going to be the same value as before. Actually, L is going to be N. If P is true, it's going to be N. Otherwise, it's going to stay as L. And this one's counting the primes. Okay, that one looks okay. So now we know how many digits we need. So we're going to use that as a length. We're going to put that in, let's put that in C, because we can recycle C now. Because now we don't need C to count anymore, because we know what the largest prime we're going to use is going to be. So now we're going to let N go up until to the largest prime. We're not counting, we're just incrementing the N. And now we actually would like to print only the ones that are actually prime. So if P, we're going to print our value N. And then we're going to write the subroutine that actually makes this in binary. Okay, so now it just prints out the first 5 primes. So now we don't want it to print this. We want it to print the bits of N. So what's this routine going to look like? Or actually, let's not even do it like that. Let's make a routine bits that prints. So we don't have to deal with arrays or chars or anything. So let's just make a void routine bits. That takes an unsigned integer. And it's going to do the printing for us. It also needs to know how many digits we're going to be printing this with. It can also be an unsigned integer. So when we call bits, we need to give it N and also the count of digits, which is C. So bits takes the number and it takes the print length. So this is the number. This is the how long I want it to be. Okay, so let's first do the stuff that would be the, actually, let's not just do it right. So now I'm interested in knowing the bits of N, and I need to be making a total of L bits. So let's make a loop. Is going to start at L. Is going to be going down. Let's make an off by 1 first so it's easier to understand. Is going to be going down. Now I'm going to actually leave it like there and decrementing. So I need to be producing bit by bit what the printout should be, and when I'm done I'm going to print the enter and return nothing. So first I need to see what is the 11th bit. What's the 11th bit? So the 11th bit we get it by pushing a 1 by L positions. Then I need to know if this bit is 1 in N. So if I make an AND between N and this 1, it's going to be 0 if there wasn't a 1 in N. So if this is true, we're printing a 0. So if, let's print a single character. Actually, we can just print it as a digit too. So if this thing is a 0, we print a 0. If it's a positive value, we print a 1. So either 0 or a 1. Closing the print. Okay, now I have a problem. It's printing nicely the 3 bits, but it's never ever printing the 1s. No, I wrote them the other way around. 1 pushing the L, not L pushing the 1. Now the 7's fine, but everybody else is a cluster now. So if I start as an L, am I getting it in the wrong order here? Bits N and C. What's the number and how many digits? What's the number and how many digits? Should be fine. This doesn't need signs either. No, the other way around. What's going on with my brain? 1 pushed by L positions. If I make an AND with that and N, then I should get a positive value if the Lth bit of N was a 1. Which means I want to print a 1. If I got a 0, it means that the Lth bit of N wasn't on. No, it's not Lth, it's I. I. Because L is where we start and I is the one we actually want. Okay, this looks pretty good, except that now it's always off by 1. It's the 1 smaller than the number I wanted. This isn't 1, this is 0. If we want to know what's going on here, I could actually print the N before we do this so that you can see what our problem here is. So now the 1 became a 0, a 2 became a 1, a 3 became a 1. So the last bit's always missing and there's always a 0 in the front. So we shouldn't start with L, we should start with L minus 1 and we should go all the way down to the 0. Oh, fuck. We should start with L minus 1. Okay, let's start with L minus 1. If I is larger than, no, actually no, let's move it here. Compile. So I needed the 1 to show up here. So the last bit never ever showed up. If I let this 2 go 0, then the 1 gets pushed 0 positions and it's just a 1. And this should... Why do we repeat forever? Okay, a little better. So the unsigned is a problem because when I go to negative, this comparison starts failing because an unsigned cannot be negative. So now I just have too many bits because I'm printing the Lth one. And if I just want the bits that are 0, 1, and 2, if I occupy 3 bits, I just need to visit position 0, 1, and 2. Because if I visit the position 3, that's already a 4th bit. Okay, this looks pretty nice. Let's ask for 15. We can get rid of the printing of the N here. Compile again. Let's ask for 30. Let's ask for 50. So now these guys here should be the first 50 prime numbers printed from smallest to largest in their binary representations with exactly the same number of bits in every single one. So inefficient parts in my code are the part where I actually find the primes twice. I find them once to figure out what's the largest one that I need to complete the 50, check how many digits it has, and then I do them again. But I don't put them in array, so I'm just using CPU, I'm not using more memory. I have a couple of little optimizations here. 1, 2, 3 are prime. None of the other even numbers are prime. I don't divide by all numbers, I only divide by even numbers. I made my own routine for the log2 in case you're ever in a compiler where it doesn't exist, but it actually does exist. I'm using the mini question for the number of digits. And then instead of returning it, I'm printing it in this routine. So I don't have to store these bits. I just spit them out as I get them. So that's how I would do homework 2. Push. Thursdays are so hard, like my brain's already all entirely asleep. Okay, so that's chapter 2, homework concluded. I'm going to check if there's any questions about this. If there's no questions anymore, there seems to be some kind of a emote spam competition on Twitch. I'm glad I'm so entertaining that everybody has tons of time to do other stuff. If there's no questions, we're going to stop the stream and I'm just going to hang out with you guys until 5 o'clock on the voice channel. If you have any other questions regarding the first 3 chapters of the book, or if you're confused about the third homework. I wanted to show you guys the exam system that I made. We're going to be looking at it closer before the, the midterm exams. But it would be kind of cool to take a little look now. I haven't linked it on the site yet because it's kind of experimental. But I've already given the link a few times on Discord. When I begin to be convinced this is actually working, we're going to link it. So you can all go there right now if you want to. Here there's actually a lie here. It says 90 minutes, but this exam doesn't take 90 minutes. I'm only going to give you guys 60 minutes. Let me go edit that. Because I made an exam that's so ridiculously easy that there's absolutely no reason to spend more than an hour on it. Everybody's going to have one sheet of paper with you when you're presenting the exam. You're going to write down your answers on that sheet of paper along with your student ID. And you're going to be sending me a picture of that before I give you your grading code. So you're going to put your student ID, you're going to put the homework email that you registered, you're going to select midterm, which is the only option now, and you're going to select practice. On the day of the exam, when you send me your student ID, I will send you a code that you will use to actually present the exam. When you're actually presenting it, the points will count towards your grade, and there will only be one attempt. When you're practicing, you can attempt as many times as you like. It's going to generate you a new exam. And this is the exam we have. It's going to say here what time it is, how long you have, and what time your exam is going to close. You need to pay attention to this. If you don't grade it before that time, it will be invalid. You'll get an NP and no points. So here we have a code. To figure out what's missing of the boxes, you sometimes have to read only that line. Sometimes you actually have to read the context to understand what's going on. I'm going to answer this one. So I need a library that does character things. C types, very good one. Text things, strings, a very good one. The conversions, they come from the standard library. Then I need to define a constant, but I don't know what it's called. So it's going to come later on in the code. We're going to find out. We have some variables. Then I want to interpret as an integer this argument. That's easy. That's A to I. If I want to interpret it as a decimal, I'm going to use A to F. Because it says here it's not a very large decimal, so I want floats instead of doubles. Then I'm going to take an input. That's easy. That's with getchar. I want to take the numeric value of a digit. So I need to subtract from C the character 0. Then I want to skip until enter. So I'm taking the character and doing something with the enter. I want to skip as long as it's not enter. Great. Oh, and here there's a max in here. We're looping a max times. So this dude's going to be the max because we didn't have a max before. Then we're iterating over remaining command line arguments, but this comment isn't closed. Let's close the comment. We're going to start at 3 because we already used the arguments 1 and 2 over here. And we're going to keep going while it's smaller than the argument count. It's j that we're using, so we need to increment j. Then apparently we're taking the argument to a variable, and then we're going to start using a variable called s. So we're probably going to put it in s. Then there's another loop that seems to be iterating over the characters of the string. And we want to do something. Let's make this a little smaller. If a lowercase version matches, okay, this is matches what? Oh, there's an input for the matching, so it needs to match C. How do I get a lowercase version? With to lower. Then I need to print the modified version, so we're doing substitutions here to S, so we need to print that string S. Then we're dividing an I by 2 while it's larger than X, and we need to print whether that number is even or odd. So if that thing in modulo 2 is 0, this looks better, because if this thing modulo 2, no. If this thing modulo 2 would be 0, yeah, it would be even if it's positive and odd if it's negative. I think my template has a problem. These texts are the other way around. We output a new line, then we return, but there's a semicolon missing, and then there's missing the curly brace at the very end. Let's grade this, and we have the 20 points. So I have to go to the template and change the even and odd around. So this is how you practice the exam. And every time you go in there, you're going to get different slots. If you keep going while the exam's still valid, like during those 60 minutes, you're going to be seeing the same questions. When you go back an hour later, you're going to be looking at new questions. So this is how it works. Please test it. Let me know on the chat how many points you're getting. And we are going to look at it again and discuss it again before we present our exam. Our exam is going to be on the 17th, so we still have 2 classes before that, I think. No, 1 class before that, so we can revisit this. But please look into it so you can actually ask me questions next week so I can answer all those questions. If you don't have a student credential, please go to SIACE. There's an option there. It's strangely named. Let's figure out what the strange name of that thing was. It's called Situación Estudiante UANL. You have to go there, and it's going to create you a digital credential, and that's the one you're going to use. The whole exam is ridiculously easy. You can do it in like 30 seconds. But let me finish the stream, give you guys the recording, and fix the bug in the template.